Imagine this. You step into a spaceship today. It launches from Earth and accelerates until it reaches 99% of the speed of light. You travel for 5 years according to your onboard clock. Then you turn around and come home. When you land, everyone you have ever known is gone. Cities have risen and fallen. Languages have changed. History books speak of you as a mysterious traveler from the distant past. Yet you feel fine. You only aged 5 years. This is not science fiction. This is real physics. And it is called time dilation. Today, we are going to break reality just a little and see why Einstein proved that time is not what you think it is. Let's start simple. Most of us feel like time is constant. 1 second is 1 second. A minute is a minute. It feels universal, like a background rhythm that everything in the universe follows. But Einstein discovered something shocking. Time is not fixed. It stretches and slows depending on speed and gravity. The faster you move through space, the slower you move through time. And the stronger the gravity, the slower time flows. This means two people can experience time at different rates. Not in theory, not in math only, in real life. Satellites orbiting Earth experience time slightly faster than we do on the surface. Their clocks must be constantly corrected or your GPS would fail within minutes. Your phone works because Einstein was right. So how does this actually work? Think of time like a river. On Earth, the river flows at a steady pace. Everyone standing on the riverbank experiences the same flow. But imagine near a black hole. Gravity there is so extreme that the river slows to a crawl. To an outside observer, time near the black hole almost freezes. A person falling toward it appears to slow down, never quite crossing the edge. Meanwhile, for the person falling in, time feels normal. They cross the boundary in seconds. Two realities happening at once. Same universe, different time. This is gravitational time dilation. Now let's look at speed. Imagine you are on a train moving smoothly down a track. You throw a ball straight up. It lands back in your hand. Simple. Now imagine someone watching the train from outside. They see the ball travel upward, but also forward since the train is moving. Same event. Two different paths depending on perspective. Einstein realized time works the same way. When you move through space, some of your motion is taken from your motion through time. Space and time are linked. This is spacetime. If you stand still, you move fully through time, 1 second per second. But if you move very fast through space, you move slower through time. At everyday speeds, this effect is tiny. You will not notice it in a car or a plane. But near the speed of light, it becomes extreme. Back to our spaceship. At 99% of light speed, time on the ship slows dramatically compared to Earth. For every year that passes on the ship, decades or centuries can pass on Earth depending on the exact speed. To the traveler, the trip feels short. To Earth, it is a journey across generations. No trick, no illusion, just physics. This leads us to a famous thought experiment called the twin paradox. Imagine twins. One stays on Earth, the other travels in a high-speed spaceship to a distant star and back. When the traveler returns, they are younger than their twin who stayed home. At first, this sounds like a paradox. Each twin sees the other moving. Shouldn't each think the other is aging slower? The resolution is that the traveling twin changes direction. They accelerate and decelerate. They switch reference frames. That breaks the symmetry. The result is clear. The traveler ages less. Again, not theory only. Astronauts on the International Space Station age a tiny bit slower than people on Earth. It is a very small difference, but it is real and measurable. So what does this mean? It means time travel to the future is already possible, not by jumping through portals, but by moving very fast or being near strong gravity. If you could build a ship that travels close to light speed, you could travel far into Earth's future. You would return younger than everyone else? The universe allows it. The limit is technology, not physics. Now here is the truly strange part. From your perspective on the ship, time feels normal. Your heart beats normally. Your thoughts feel normal. You do not feel slowed down. Only when you compare clocks with someone who stayed behind do you see the difference. This tells us time is not something universal. It is personal, local, relative. Each observer carries their own clock through space-time. Reality is not one shared timeline. It is a web of intersecting timelines, each shaped by motion and gravity. Once you understand this, the universe feels very different. Let's return to the river analogy one more time. You are not just drifting down a river of time. You are moving through a four-dimensional landscape. Your path through space affects your path through time. Near a black hole, the river slows. At high speed, the river narrows. The universe is flexible, dynamic. alive. Einstein did not just change physics, he changed our understanding of existence. So the next time you look at the stars, remember this. Somewhere out there, time may be flowing slower or faster. Entire civilizations could be experiencing the universe at a different pace than we are. The universe is not a fixed stage. It is a shifting fabric, and we are all moving through it in our own way. And this brings us to the question that always follows. If time can slow, can we travel backward? That story is even stranger, and we will explore it next. If you want to understand how real-time travel works and why the twin paradox proves it, hit subscribe and join me in the next video, because the universe is weirder than you think. And we are just getting started.